So in the next section, 3-3, we learn about optimization with linear programming. And so basically we're going to continue looking at the inequalities and bounded regions and so on. So if you will look at the slide 18, which is the first slide of the 3.3, you'll notice that it gives you certain steps to follow to be able to solve some of these type of problems. So if you notice, step one would be to define the variables. So obviously make sure you understand what the variables that you're using are. And usually it's the first letter of like the whatever label of the item that you're looking at. So of course, then you try to write that system of inequalities. Then you're going to graph the system. So if you notice the example that they give here on slide 22, that's exactly what's happening. So you kind of draw all those lines. Find the coordinates of the vertices. Remember, vertices are these points right here, where you can see of whatever figure that you form, right? And then, of course, you try to write functions, linear functions, to demonstrate those unless they're given to you, right? And then you substitute the coordinates of the vertices into the function, and then you select the greatest or least result. So that way you can answer whatever question that they give you. So here you'll find some examples and explanations of a real world example. And so they want you to find the coordinates of the vertices of a region that is going to be formed, right, when you do all those equation graphing. And so you just continue with the questions. So let's go to the study guide and intervention. These are not a lot of questions here for you to practice, so we'll just maybe work on one or so. So if you notice, it does say to graph each system of inequalities and then give the coordinates of the vertices and show the region that it's going to form, right? So find the maximum and minimum values of the function and so on. So basically, you're going to graph these equations and you're going to try to see what kind of region is formed. So let me pick a problem. There's some more information there for you and so on. So let's try question number 1 of this set. So let's start graphing these equations. So we start with inequalities, right? We start with looking at this first one here. What I notice is it's kind of in the right order, except, kind of backwards, right? So I'm just going to flip it around. Give me one sec. Back to the problem. So I think it was a little bit lower. So let's go ahead and rewrite this. This is y. Notice how the open side is towards the y here. So I'm gonna make sure flip everything like that. Is 2x minus 4. So I just switched this around to make it look like that y equals mx plus b format. Same thing here. If you see, I could just flip it around, y greater than or equal to negative 2x minus 4. And of course, this stays the same. So let's go ahead and graph the 3. I'm going to start with this one. I see that as a Hoy since it's y equals. And so I'm going to go ahead and graph it as a horizontal line. Keep in mind that it does have a bar, so I'm going to make a solid line. So y is 2 is here. And so I'm going to go ahead and make a solid line there. So that is your y is less than or equal to 2. Well, since I would have to shade this, I'm going to wait a little bit so I can shade just the region that is bounded by these 3 equations. So let me do the next one. So the first one here has a y-intercept of negative 4. So I'm going to go here to 1, 2, 3, negative 4. And the slope is 2 over 1. So I'm going to rise 2, run 1, rise 2, run 1, etc. Something like that. So I'm going to be looking at the region that is greater than that. So I'll be doing that in just a bit. And the final region in question is this right here, where if you notice it's a negative 2 over 1, so the slope is negative, so it's going to be a line coming down this way. And the y-intercept is still negative 4, So I'm going to still come down here to -4, but this time instead of going up 2, I'm going to go down 2. So let me propose something to you. If you give the negative to the -1 down here, so I'm going to be doing this instead. It's the same thing. As long as there's only one negative, either the top is negative or the bottom, when it comes to division, it's still going to be the same thing. So the reason I'm doing that is so that I can go upwards. So if it's +2, I go up 2, but check it out. If it's -1, I go left 1. Instead of like on this one, I went to the right. Do it again, up 2, left 1, up 2, left 1. So I'm dealing with some kind of figure like this. Sorry about that, guys. I'm trying to get it as straight as possible. So I think we already see the figure that is in question. Let me see if I can highlight the area. So it's all this stuff inside this, looks like a triangle. All right, so now once you found the bounded area, all you need to do is find the vertices. So this one is pretty easy, it seems. It looks like it's x is 1, 2, 3, up 2, so 3, 2. Then this one's going to be a little harder since it's outside of the graph that they gave me. But I can still figure it out. So on the x, it's going to be -1, -2, about -3, and up 1, 2, it seems. So -3, oops, -3 up 2. That's another one of the vertices. And it looks like the last vertex is down here that I need to find. So if you remember, this was -1, -2, -3, -4. So on the y, it's -4, and x is 0 since that is the y-intercept. So let's see what the instructions were. It says to graph each system. I've already done that. Name the coordinates of the vertices. I've done that. Of the feasible region, I've showed that in yellow. Find the maximum and minimum values of the function. To do that, we use this equation right here, and we just substitute. It looks like this might pretty well be my minimum, so let me substitute that. So I'm just going to make a little table here. It's not like your typical x and y. I'm just checking for this value, what happens when I substitute it in here to see if it's a minimum or a maximum value. All right, so in this case, x would be 0. So 2 times 0 is 0, and then here I would have -4. So this would just be -4. Let's try the others. 3, 2, because I still have to find the maximum, and minus will make sure that that one was the minimum. All right, so now we substitute this here. So if we do that, now I'm looking at substituting the 3 for the x, and then substituting a 2 for the y. So if that's the case, then this is -2 times 3 is -6 plus 2. I end up with, oh, check it out. So getting kind of the same answer. And then if I do the next one, this would be a -3. So this would turn into a +6 and 8. So it does look like my minimum value is still that -4, came from either one of these. And if you look, it makes sense. I mean, look, it's a straight line that way. And the maximum value that this creates is the number